Perfect. Well, thanks everyone. Jim, thanks for the introduction. So yeah, it's been great helping build out Snowflake's ecosystem of data science partners. And what's been really eye-opening is in the last 6 months or so, our customers have been asking us questions about feature stores over and over and over again. So I made a concerted effort to reach out to as many feature store providers as there are out there. So spent quite a bit of time with Jim and Yaron and several of the other partners of the Feature Store Summit. So excited to see everyone here. But yeah, let's see if everybody's on. We've got a panel of 6 folks today. And then Aman, David, Moritz, Weipeng, and Yaron have already had sessions earlier today. The only person that's a guest panelist today is Rika. And just a little bit of background on her. Rika is a senior principal engineer at Disney. She leads the ML engineering team that drives the strategy for ML infrastructure and applications. And she's excited to leverage machine learning for engineering and engineering of ML. So with that, let's go ahead and dive in. As Jim said, we have about 30 minutes and quite a few questions to cover. So the first one that really comes to mind for me is, again, this concept of a feature store. I heard it for the first time about 6 months ago, but most of our panelists have been engaging with feature stores for quite a while. So Rika, maybe you can tell us a little bit more of when was the first time you heard of a feature store or this concept of a feature store? How long ago was that?
Thanks, Mike. Yeah, I first heard at a meetup, I think, back in 2016, 2017. It was a local meetup in Bay Area with Uber, Netflix, Airbnb, and a bunch of folks. And at the time, they mentioned that they were working on an ML platform, and we were talking about the ML platform, how things are. And the notion of feature store was introduced. But I think what it meant then to how it has evolved, I think it has been quite a rapid change since then, from it being a bunch of tables with primitives to it being a fully baked technology on its own.
Awesome. And then Moritz, do you have some perspective on feature store? When was the first time you heard the term feature store?
Yeah, I actually heard the first time about it when I was working on projects with Deutsche Telekom in Germany. They were implementing some APIs and stuff, which they called a feature store. So that was the first time I heard about it in 2017, and then 2018 I think came the Michelangelo blog post where I heard properly about it the first time.
Awesome. And then anybody else, if you want to jump in, if you have a story, feel free to jump in and share that.
I'll jump in quickly. Yeah, I think it's about the same time Salesforce, we heard about it too. Michelangelo definitely did a great job putting that concept out first. But I think from then to now, probably David, you touched base on this one a little bit too. There are some questions around there, even from the organizational side. People ask, well, if you need this, why don't you just go ahead and use HBase and store things there? And in fact, that's what we were doing. We compute some of those features, especially when it comes to classic machine learning. You have this cron job, probably computes those values, store into HBase, and then have a key to compute that and take it out. So organizational wise, to actually say that we need to form a team and properly treat this and deal with this whole thing as operationalize, it actually was a little bit hard to sell because I don't think people fully understood the complexity behind this. And I think the past few years, the more and more different type of AI application comes up, and as we need to build a lot more, I think this part sticks a lot more with the organization now. So yeah, not surprisingly to see a lot of the big companies starting to have that part of the look. And even like SageMaker, Vertex AI, they all starting to have this offering too.
Great. So this brings us to the next question of, if you had to pick and settle on 3 defining characteristics of a feature store, what would those be? And the reason I think this is an interesting question is, again, I've talked with lots of different vendors out there, and everybody has a slightly different perspective on what is a feature store and what should those capabilities be? But I think among us, we could probably settle on those 3 defining characteristics. So actually, Wai-Ping, do you want to give us your perspective on what those 3 characteristics would be?
Sure. Yeah. Well, I think I kind of touched that a little bit. Operationalization, I think that's definitely, I put that by understand is that keyword itself definitely contains a little more extra meaning to it. Like it contains probably scaling and also automating all that stuff behind. So operationalization, consistency, and secure. I think if I can only limit to top 3, that would be the 3 I would choose.
Awesome. Perfect. And then Yaron, if you're still on, love to get your perspective on what you would say are the 3 defining characteristics of a feature store.
Yeah, so in the past we did have catalogs and we have ETLs and companies like Informatica, etc. And sometimes when we speak to customers, they tend to confuse, and because many people still think of feature store as a way to catalog features and like maybe run ETL jobs, etc. I think what makes feature stores different is first the automation transformation pipeline, etc., not just the cataloging and making the features available for both online and offline use. So this is really the thing that allows, because most organizations know how to deal with the offline. They run some database queries, and especially with data warehouses like yours, etc., it makes the life simple. But building an online pipeline, this is really what makes things very, very hard. Kafka and streaming and Flink and all that. So I think that part makes it a feature store. Another part is making it more glueless into the machine learning sort of frameworks. So you can essentially, integrate with pandas and integrate with model serving, et cetera, where the ETL frameworks are essentially building some data set that you query with JDBC or with the Hadoop or whatever. So I think the glueless nature into the workflow of the data science, the operational workflow data science, and also not just dealing with analytics features that are like the traditional database ones like group by and join, etc., but also features that are like encodings and imputing and etc. And potentially there was actually one question in the Slack for me was around, do you handle unstructured data? Yes, there are some pipelines that are very complex NLP pipelines that we work with financial services, document processing and so on. And there are pipelines that involve even image processing. So I think this makes it a feature store versus an ETL pipeline.
Excellent. Aman, question for you. At Spotify, do you have any additional or special requirements for how you use a feature store? Yaron brought up unstructured data. So I imagine at Spotify, you might be doing something with audio files.
Yeah, that's a great question. So I mean, just sort of even just trying to tie this back to the 3 qualities of a feature store. I mean, the way we look at it is, this abstraction needs to sort of possess like kind of three principles that we kind of look at, which are usability, extensibility, and trust. Usability, like feature store, needs to be easy to use. It needs to be something that a user can get started with right away, and sort of be able to manage features throughout their life cycle from experimentation to production. Ultimately what we're driving towards here is adoption, just like any other sort of B2B tool. We kind of think of ourselves as an internal B2B tool here, because if they're not using it, they're not going to get value from it. Extensibility is really the part where I think, coming to your question, we realize that across Spotify, there are like a number of different use cases that, for instance, our search team does some complex, NLP processing work, which, it has to be done at sort of more closer to like near real time and low latency sort of requirements that sort of constrain that problem a little bit more. But that's very different than our recommender systems that might be, doing more sort of batch inference. And even some of those are near real time in different ways and using data in different ways. Daniel in a talk earlier mentioned we heavily use embeddings, which can contain things like, audio data that's in the form of an embedding, or unstructured data in the form of an embedding. And so ultimately, it really comes down to just the vast array of use cases that we need to support the feature store needs to be able to be extensible across all of these different use cases, and exactly as Yaron mentioned as well. And then the last piece I would say is that trust component, which comes down to governance, lineage, and consistency, which is what David mentioned earlier as well. You know, that offline online consistency is like the foundation there. But going forward, you know, having trust that the features themselves are high quality and that they can be traceable, and you know, that's really like a core principle when you're working with large amounts of data.
Great. And then Rekha, what about you at Disney? Do you have any unique requirements for your feature store?
So I think given the few things like usability and consistency are the key things. In addition to that, some of the problems that Aman was referring to, we sort of have a mix of nearline, online, and batch pipelines for features. So consistency is one. The second is also discovery to reduce reuse of things. So we have enormous content catalog, and that catalog is used in tons of ways, and there are hundreds or thousands of features derived from the same piece of content or same set of content. And how do we ensure sort of a streamlined reuse of that? So I would say reusability is one thing that we care a lot about, in addition, and the composability, which is sort of similar to extensibility, but not exactly, because we want like features to be in different steps, like first layer features or summary aggregates, but also ones that are closest to the model. And we want to be able to compose and combine them in a flexible manner. So I would say reusability, composability, in addition to the other things that my other folks have. So they covered sort of other basic features.
Awesome. And then David, what about you at Twitter? Are there any specific or very unique requirements you have of your feature store?
Yeah, I think something, you can hear me all right, right?
Yep.
Okay, cool. I think something that's challenging is in an ideal world, we would have kind of our singular offline store, data warehouse, BigQuery, data flows through that, data gets joined through that. And our process of joining in that feature data would be uniform, but it's actually not the case. At different scales, there are actually different requirements and issues. For instance, for some of our largest data sets, they just don't work in BigQuery. For these data sets, there's over 5,000 features and billions of rows, and performing any even minor operations in BigQuery takes a really long time. And due to that case, we have to provide a different solution that's based on their data living in GCS, potentially joining in their data in GCS and not having to make the round trip around BigQuery. So that's kind of one active topic that we're thinking about. If any of the panelists or anybody else in the audience has any ideas around that, feel free to ping me, because I'd love to hear it.
So that sounds like a real scale, not necessarily problem, but a benefit. I mean, if you have 5,000 different features defined for your data, that's incredible.
Yeah, it's for somebody who's managing the platform, it can be a pain. But I'm sure for the people who are working on the models, they're excited about the results being seen from that.
What ways do you provide then for the data scientists to select among those features and find the right one for them?
Yeah, we have a feature importance tool. So there are various ways to figure out, if certain features are basically representing the same sort of signal, and you can maybe cut down on the features. So with that tool, we have some information on previous experiments on which features were most important in the outcome of or the prediction and the outcome of the experiment. And those are the features that we hope to encourage other teams to try out.
David, you brought up a good point, right? As the person kind of managing the system, can you tell us a little bit about what that team looks like? How many people are managing and overseeing your feature store? And then also on the other side, how many people are consuming from that feature store?
Yeah, so for our team, we currently have, I think, almost 14 people just working on feature management and the feature store. And our efforts are split between our 1.0 feature store infrastructure and 2.0. So 1.0 was our completely virtualized one that most teams are still based off of. The new 2.0 one is the one we're developing that we're still getting our initial users and usage from. And as for how many people are using our feature store, all the major teams at Twitter use the feature store, like ads, timelines, health, abuse. So we get a good set of usage for our 1.0, and our 2.0 is still being built out.
Thanks, David. What about you, Wei Ping? How many people on your team support your feature store, and then how many consumers of that feature store do you have?
Yeah, well, David, I definitely feel you. It's one side of the story to say, hey, I'm going to use some and be able to support this many different teams. It's definitely headache and work, challenging, but it's fun. From our side, it's actually hard to decide about the number because feature store itself and our ML Lake, it's actually work hand in hand. And we also have another team called the data pipeline team. And we also have metrics team. So overall, our platform team side, we have about roughly 200 engineers, but the entire company, we're talking about 70,000 employees. The app team size as of now, I think it was still shaping up, probably most of the big company as well. We know AI can be infused in almost every aspect of it. By finding the right set of feature and build application, it's a gradual process. The more we build up and the more we're enabling some of those normal, what do we call regular software engineers to become a AI product builder too. So that number is also moving. Ratio-wise, I'm a platform person, so I would always want to be able to have a strong foundation for this to scale up for this big of a demand.
You brought up something really interesting, which was metrics. Can you tell us a little bit more of how you view metrics differently from your feature store and the features?
Sure. Yeah, so I think actually one is an outcome or observation of the other. Metrics in particular, I think the definition of that, again, can be very interesting. People may or may not fully agree. There's operation metrics, there's ML metrics. And even for ML metrics, it comes with data metrics, training time metrics, runtime, and inference metrics. And then also holistically, you compare all the models you trained out. And because we are multi-tenant as well, one set of algorithm, we like to provide many different tenant-specific models. Are they performing correctly? So we do have offline computation in place. It's first part is the collecting all of them. So we have Kafka bus. Many different places will be emitting those data points, and they land into Kafka bus with different topics, and they aggregate into different data sets. And those data sets sometimes is to look at the data metrics, see how they drift. And then at the same time, feature value too, because the feature value works with the model. And if the feature also drift as well, those are all good indication for us to say, hey, things need to be refreshed. So yeah, there's quite a bit of interesting things on the metric side too.
Perfect. And then from my experience, most people, when they think of a feature store, they think of data science and machine learning as really the primary consumer. At any of your organizations, do you have business intelligence groups or people that are building reports that are consuming features from your feature store?
Yep. So actually, at least some of the earlier versions came out because we needed BI and reporting. And it was tagged as metric store, and some of the work was done. And now we are kind of taking that work, integrating into the general feature store and making part of it. So I think those two features, I mean, just because we call them features, like they're attributes and they're information about your ecosystem, and they can be used in the ML models as well as for reporting and other ad hoc analyses as well, including experimentation and such.
Yeah, maybe I can chime in also around it. One of the things that we did in our implementation is provide different types of material views. Usually people refer to like online and offline, like a data warehouse or Parquet files, and then like online is more like a key value store. And we also, for example, support time series databases or streaming material views. So you can actually write the feature results into a time series layout, and then just put like a Grafana dashboard or something else on the features in sort of a glueless way, and you get, because what is the outcome of machine learning workload? Sometimes it's an inferencing and an action. Sometimes someone wants to just look at the predictive dashboard, which can actually. And by the way, this also is the question: where does the machine learning end and where does the feature store ends? Because you can say, what about the prediction? Is it also a feature? Like I have a value of something, and then I have a predicted value of potential, fraud or again risk, etc. This could actually also be viewed as another feature, which is just calculated using a machine learning model. So you can actually look at it both ways.
Yeah, and several of you brought up reusability as a key benefit of a feature store. So I think having that reusability, not just within the machine learning aspects, but reusability across the organization. And then you can help create that alignment between the business intelligence users, the analysts, the business users, and the data scientists. So yeah, I think feature store can apply to much more than just ML. Awesome. Cool. Let's see. Does anyone have an example or a big benefit that one of their teams experienced once you implemented a feature store? And I'm thinking more specifically from a business side, right? Was there like an aha moment where somebody that was struggling and all of a sudden you guys launched a feature store and they were able to get to their business value much more quickly or get more accurate results?
I think the real value that we've seen is that it empowered data scientists to build analytic pipelines, where before they had to go through another feature data engineering team to build anything they need. So now they can actually go and build some Python classes or sort of a Python DAG, and off you go. You have a highly scalable, very powerful sort of feature engineering pipeline. And so that accelerates the process because you don't depend anymore on the DevOps people, the data engineering people to bring up Spark and all of that stuff.
I think actually touching on what you just mentioned, Mike, one of the main benefits that we've seen so far has been around kind of reusability of features. At least like that's one of the main incentives here for us. And that's largely due to like the organizational nature. I mean, when the number of teams using machine learning is so broad, they need to move quickly, and they'll often end up building their own infrastructure and pipelines. And if these tools aren't talking to each other in some way, or there's no centralization of these, highly complex transformed data sets in the form of features, a lot of that work goes to waste. And so we've seen benefits of teams that were producing data or features on one side of the organization completely unconnected to another, and all of a sudden they're now sort of talking to each other and organizing around a use case, and you can now connect business value much more directly to in places that you wouldn't have expected. So that was one unexpected, but also a huge benefit that we've been noticing.
Yeah, I can't agree more on this one. I think essentially we know there's many of very good use cases we can do with AI to empower our end user. But the thing is that in the past, it can easily take, like, especially for us, we build on a multi-tenant way. Each tenant needs their own tenant-specific model. It usually takes like almost a year just to get this whole one application out to GA, because our definition of GA is any data shape should be able to use the same algorithm to somehow train a model and perform more or less good enough for them. So this part of the work, like having some of those teams each build their own foundation. And with those features, like, we look at each other like, oh my God, I can't believe you do this. How do I use that? And this part of the sharing enabled the team to be a lot faster, because things are already there. If you leverage those feature computed already and understood what generates that, and the reverse part of it, it's how do we use inference to directly use those. It makes an AI application build a lot faster.
I had a question on this topic that I wanted to ask the panel. So yeah, one issue that we deal with is sometimes a team, over a span of maybe multiple years or a long time, does a bunch of experiments and they build out or they register certain data pipelines. And other teams, because of the sharing and reusability factor, start using these pipelines. But the original team who started the pipelines no longer is invested in these pipelines because their newer models don't use these features. But yet they still have to maintain them because as a feature store team, we can't maintain the pipelines for all our customer teams. So that's kind of one issue that I wonder if you guys had any thoughts on, where you have customer teams now obligated to support pipelines that maybe aren't as high value to them as before.
I don't think I have a full answer, but I'll jump in for a little bit of my view to this as well. To me, I feel like feature sharing, there's a two level. One is you share the algorithm. Another one is you share the data. So of course, the algorithm goes with the actual operation, and that outcome is the feature value. I think especially when it comes to the team no longer need that, the platform team usually would be the one owns the operationalization part. So the pipeline is owned by the platform team. That helps once you have a stable platform. So the team who wants to share with another team, they can share by data if they are in the phase of both needing it. But the second that they graduate to the next phase, I say at that point, you probably should do by share the algorithm. So the team can take over the algorithm and then the platform continue to run. And that's how I see this relationship can evolve.
Got it.
I would agree with Weifeng's example as well. Actually, we're still fairly early in this journey of there are like a couple of instances of this happening, but largely that separation between the data layer and the calculator transformation algorithm layer is one approach that we take. We have a core data infrastructure team that manages data sets that are critical to the business, and so those are, if there's deprecation or new versions, that's usually handled in sort of like as data as its own product. And then from the algorithm side, we build tools to make that easier to manage and allow teams to spin up these sort of features easily on their own data store as well. So just making it available, you can kind of get that information around lineage and if I should be using this data set or not for my use case.
Yeah, but I think that one of the ways to address this complexity is by introducing sort of abstractions. Like if every feature is calculated using tons of SQL, then probably no one will be able to maintain it. But if instead, if you've seen one of the things I demonstrated, you build classes that are common use cases like aggregation, one-of-them encoding, etc. And then your code becomes sort of pseudocode. You can describe the same thing in a few lines of code, and then someone else can go and figure it out without trying to track all the select statements and from and so on in a SQL query. I think, and then the sort of the feature store team is the one maintaining those common abstractions or common classes that are used across the,
And Yaron, earlier you brought up this concept of almost self-service, where data scientists can, instead of having to go to a data engineering or a DevOps team to build out these pipelines, they can just do it themselves. But on the flip side of self-service is this whole concept of proliferation, because you've now enabled a lot of people to go ahead and build out all these features. And then David, you mentioned, you have 5,000 features in one of your tables or in one of your feature stores. How does everybody manage the scale and the scope of features and this kind of sprawl? Obviously you can do versioning and deprecation, but how do you handle having so many features and managing all these pipelines?
So we actually have a single application and one of the major providers running 10,000 features on a single recommendation engine that is being fed by 70 different data sources, including sort of real-time and offline and data warehouses and whatever you can think of, even like geolocation updates coming from streaming and so on. So I think there are different aspects of scale. I think the real challenge of the scale is not necessarily the number of features, is actually dealing with the massive ingestion of data in such an application and like doing the join, the groupings and all that on so much data. So you have to come with an architecture which is very horizontally scalable. You need to think through how to build it for such massive scale. I'm not sure like how many application will use 10,000 features. So I don't think the management of the metadata is really the aspect. You could put labels on features, etc., and manage it this way. I think the real challenge is doing the actual data processing for 10,000 features, and creating a single feature vector in the scoring engine, which was one of the key problems we had in terms of performance. Is how do you essentially join 10,000 features every user requests? So again, we've introduced several very cool technologies for like vector queries and things like that into the, we have our own real-time database that supports sort of the key value aspect with some special primitive just to deal with that scale problem.
Maybe something to add to this one is I think self-serving is definitely something as a platform builder person always wanted to achieve, because we only have two hands. We can't hold hands with them all the time. But at the same time, I think it's when you wanted to do that, you need to build another layer, what I call it, platform governance. So when you give this to people as a self-serving infrastructure, what are the limitations you need to build in? There's a few things we do, like for each of those applications, we ask them to do some level of capacity planning. So you are only giving this much CPUs, GPUs, memories for this particular type of pipeline. And so they are fully aware. They need to tell us what's the actual production traffic. And to some degree, it's predictable as well. So with that, we will make some of their jobs to wait. If you tell us I only need 800 megabytes, just hypothetically, and if you reach that limit, another job of your application in particular will have to wait. So the whole platform, looking at the whole thing holistically, it also forced the app team to also think about this. Do I really need to compute this? If I have to wait, I might also go to another team. You compute this, make a little bit of a change that can make it useful for me as well. So it's a push and a pull kind of relationship there.
So there's a people and process component of it, as you said. You have set certain expectations and then people have to fulfill those. And I think, David, that was kind of going back to your point too, where certain people might create features and then they no longer need them, but they have to continue maintaining them. And that's just part of the responsibility of having access to a feature store. And also, I guess the privilege of having other people reuse your features, right? Now that they've become part of the business process, once you build it, you kind of have to own it. Awesome. So we're almost at time here. To wrap up, I was hoping that we could kind of go round robin and get some tips and tricks for people that are just starting to think about feature stores. So, David, maybe we can start with you. Do you have a tip or two that you would give to our audience that's just getting started with feature stores?
I think there are, compared to even like 3 or 4 years ago, there's a lot more new technologies around this. Some proprietary, some open source, some are businesses. And to get a better sense of what it's like operating a feature store, I would really recommend just diving in and trying it out. I think there's a reason why at every conference we have to answer the question, what is a feature store? And I think if you dig deep, try it out, pick a basic use case, and just get a feel of what it's like working with it. Is it easy to use? Is it confusing? It'll really be helpful for thinking about whether you want to go further in this journey.
So don't be scared, dive in, start small, and then kind of learn how to adapt it to your organization. Cool.
Yeah.
Moritz, how about you?
Yeah, I think the key to most of the questions we discussed now is metadata. So keep always the metadata in mind, and then make it easy to enhance with metadata and like make the data science teams own the metadata basically, so that then responsibilities and governance becomes clear from the metadata. So I think the whole part of discoverability, reusability, all comes from the metadata, but at the same time, don't leave the infrastructure out of sight. So while some people see feature store purely as a data catalog, others might see it only as a infrastructure topic, like online and online and offline storage. But I think the combination of the two is the important part. Yeah.
Wei Ping, you want to go next?
Oh, yeah, sure. So I think those are really good points already. Something to add is definitely make sure you choose the metadata and choose the right concepts. Or I think a lot of feature store vendors out there, most of them have the concept of feature sets and feature table, and I think the lineage and all that stuff is in place. However, I think it's important to see of things that can be gradually standardized across, because the last thing you wanted to do, especially from a platform's perspective, if you support many different applications, last thing you wanted to do is to yank that blanket underneath it and then cause a lot of migration process. Define that if you choose the solution that's relatively standardized already, underneath it, a lot of those new things can be added. Like I think someone asked on Slack channel or somewhere about, oh, how we support the time series and all that. Yes, we can actually gradually add those into the system as long as you have that layer of standardization abstraction built out already. Yeah, I think this part is going to evolve more for sure, and look forward to all the comments and also collaboration going forward too.
I would build off of that as well, and just say it like when we were thinking about what to do for this new version of Jukebox, like the most important thing was just picking the right use cases as well. So find the ones that, as David and Wei Ping were mentioning, was find the ones that can be generalized and are sort of most critical to the business. Don't pick necessarily the hardest one first. Like, yeah, your ML practitioners might come up and say we need features in like sub 10 milliseconds, and we have all these complex requirements. That's great, but try to pick the ones that you can actually bite off and might be supported by tooling that's out there already, either through open source or through enterprise tools, and then slowly and gradually add more functionality as you need to. Because if you'll find that if a certain solution doesn't work for you, you might have to migrate to something else. So yeah, that would be my advice.
Great point. And then what about you, Rekha? Do you have any tips or suggestions for folks that are just getting started with feature stores?
I would say like tag along, like looking at your use cases, in addition to like also looking at the volume and scale. Not all use cases. So like some of the batch use cases, you need like high throughput from your feature store. And if 80 or 90% of your use cases are batch mode, then using a solution that optimizes for online store is not going to work. So sort of like horses for courses kind of a strategy where you have a good understanding of what your use cases are, what your access patterns and volume and scale is today and going forward, so that you can pick the right solution. And sometimes it might be that you use a piece of a solution, like a vendor offered product, and build the rest of the things so that you can better integrate in your ecosystem.
Awesome. Well, thank you so much, everyone, for.
If I can chime in, Mike, also for
Go for
it. for my part of this. I think, again, a lot of people look at the feature store as a standalone thing. And I think Wei Ping also mentioned Matrix and et cetera. We see exactly the same thing as, and the discussion here was around quota, et cetera. So I think when you're looking into that, don't say, okay, I'm going to buy a feature store and then I'm going to deal later with how I'm going to collect the telemetry and do model monitoring and drift, and then how I'm going to handle, resource quotas and management. The approach that we've taken, which are slightly more holistic on the operational pipeline, it was sort of out of necessity. We've seen that if you're just saying, okay, I'm going to deliver a feature store, someone else needs to build all that glue for the serving. So, and someone else needs to figure out how to do imputing and missing value substitution in like sort of real time. And you know what? But I do have all the statistics in the feature store. So why can't I? Like one of the things that we're trying over and over to do is reduce the lines of code needed for glue. That's sort of at least my agenda as a CTO. And I think that's why when you're evaluating something, don't look just at, okay, I'm going to have query, online, offline features, but how am I going to deal with the rest of the operational pipeline, and how well the feature stories integrate with the rest of my operational pipeline, including, resource management and telemetry and all those parts.
Awesome, great points. So again, thank you, everyone. Thank you specifically to the panelists for your time and your input and your insights. Sounds like there's quite a few questions on Slack, so we'll be on there answering those over the next few minutes. And then thank you to the audience, and also thanks to Hopsworks and Jim for having us partner with you on this. Thanks, everyone.